everyone. We want to find the surface area of a surface in 3 dimensions. And in order to do that, I want you to conceptualize, I have an object here and I want to find its surface area. If I project this directly onto the floor, it'll create a shadow that's a geometric shape. If I find the area of the shadow, that won't be the same as this area here because of the tilt. So I would need to figure out what to multiply the area that I've created in the xy plane. So in my illustration here, I have a 3-dimensional surface, and what I'm going to do is take a section of area and then project it onto the xy plane. Now, this area here is clearly just the region in the xy plane, but this should be much smaller than this unless this was completely horizontal. So what we need to do is figure out how to find this area in order to figure out what the multiplier is. So from this point of view, if I create vectors that describe this, let's call this vector A and this vector B, vector A running along the x direction, vector B running along the y direction, then if I said in the xz plane, the slope would simply be the partial derivative with respect to x, and in the yz plane, it would be the partial derivative with respect to y. So if I was trying to figure out how to set this up as a slope, then if I go simply delta x in the x direction, I would multiply it by fx to create a situation where I have the slope. So if you see here, the a vector, which would have 0 y component, would look like this because the ratio of here to here would be the slope. And then the b vector, which has 0 for the x direction, and you see the ratio here to here is also the slope. I want to find the area of this piece, which simply means I need the cross product and find the length of the cross product. So if we compute A cross B here, we know we're going to get negative fx delta x delta y. And then from here, negative fy delta x delta y. And then finally here, just delta x delta y. The fact that these are negative are not important because we're going to be finding its magnitude. So if I said what is the length of the cross product, well, first of all, you notice we can factor out a delta xy out of each term, so we'll do that. And then I just have to square this, the 1, and then the delta xi, delta yi will factor out. So it turns out this is the multiplier I need in order to determine the ratio from here to here. Now, using that and doing the Riemann sum, by the time we take the limit of the Riemann sum, we'll get a double integral of this form. My integrand is exactly the multiplier we just derived. I will integrate over the region in the xy plane. Now check Canvas for some detailed notes on problems of this nature.